X-rays are actually kinds of light, but this light is different from the light we usually know. It can pass through the human body after certain objects, but the eyes cannot see it. Essentially, light is again an electromagnetic wave, an energy message that relays on the transmission of photons. However, there is a visible and invisible light, and the human eye has evolved over time to be sensitive to light only in the wavelength band of about 380 to 780 nanometer. Hence, the electromagnetic wave in this particular band are called visible light. In addition to the visible light, there are many other lights that are invisible to the human eye, such as radio waves, infrared, ultraviolet, X-rays, and gamma rays, which fall into the category of invisible light, all of which are in particular band and frequency of the electromagnetic spectrum. These invisible light have low and high energies, which you can see very clearly in the diagram. It is not enough to know about X-rays, we should also know how to make them. When people take X-rays in hospital, they use an instrument called X-tube. The basic principle is that we pressurize the cathode and emit a beam of electrons to bombard the anode, usually metal such as tungsten or rhodium. The electrons stay down in the anode, and the kinetic energy lost is converted into photons. When the voltage on the cathode is high, the photon energy we obtain reaches the wavelength range of the X-rays. X-rays are electromagnetic waves that can only to gamma rays, and are therefore very penetrating. When X-rays hit the body, some are absorbed by body substance, and most pass through the atomic gaps. X-rays are mainly used to detect skeletal lesions, but they are also useful for detecting soft tissue lesions. The principle of X-ray photography is based on the fact that there are differences in the distance and the thickness of the body tissues. And when X-rays pass through different tissues of the body, they are absorbed differently. So the amount of X-rays that reach the screen or film varies, resulting in image with different contrast between light and dark or black and white.